Hello, this is Matt Montgomery, Sales Agronomist with Burris. Welcome to Session 2 of our nematode series. And today we're going to focus on probably the most famous nematode of all nematodes, the soybean cyst nematode. Now, if you haven't listened to Session 1, we'd encourage you to go back to that, our introduction to nematodes and nematology and nematode anatomy, and then come back to Session 2. Let's start out in a little different way. Some people might think that we're putting the cart before the horse, so to speak, but I want to talk a little bit about, as we get started talking about soybean cyst nematode, how that thing moves around. You can see over on the lower right-hand corner some pictures I've taken in the past of soybean cyst nematode. These are the females, full of eggs, deceased. These are the critters that we're looking for in a soil sample under the microscope, and you can tell they've been magnified here. Remember, these things are only about the size of a period at the end of a sentence. They don't move very far on their own. We know that they came in accidentally as we prepped ground for the production of soybeans back in the 50s, and since that time, the movement of soil on implements is really what has moved soybean cyst nematode across the Midwest. Let's just kind of take a look here at how that thing has moved around. It'll give you an idea of how interconnected agriculture is, how we move equipment around and actually spread this thing on our own from that first introduction in the late 50s. You can see this is the distribution of soybean cyst nematode as of 1990. You see, as of 1990, it basically was distributed throughout the Midwest. And if you look at 2014, it's basically everywhere. If you produce beans, soybean cyst nematode is in your neighborhood. Now remember, from that little blip just down south of the state of Illinois that we started out with in the late 1950s, we've had that thing move throughout the Midwest, primarily by the movement of soil on implements. So it's really that method that has moved this very small, microscopic, and very damaging pest from field to field across the area that we produce beans in. Now remember, soybean cyst nematode is a little different from some of the other nematodes that we'll talk about. In our next session, we'll actually talk about corn nematodes. Soybean cyst nematode actually changes its appearance a little bit as it gets mature. Basically, the cyst nematode female becomes pregnant, her body swells up with eggs, and you can see here in this example a swollen female, a gravid female, full of eggs. Her body's inflated and she has died, and now her body has become a protective covering for all those eggs within. Remember, soybean cyst nematode is one of the most devastating pests of beans. There are very few pests in beans that cause the kind of yield losses that we talk about here. We can talk about 5 to 20% yield losses from this little pencil point sized pest in the soil. Now, you can actually burst that soybean cyst nematode female with a pin, and you can see some of the other parts of the life cycle displayed when you burst that pest open. And you can see here in this picture, we've ruptured the female. Remember, I said her body is housing eggs within. Its body has been ruptured and the eggs have spilled out. And these little gel cap shaped things here on the left are the actual eggs of the cyst nematode itself. Those are the little small, even smaller than a pencil point, objects that will eventually produce more females that will suck juices from the root and cause yield loss, cause us to abort pods, have malformed, maybe less developed pods during reproduction time. And this is an example of an egg kind of magnified. This is actually from an old extension publication that shows what soybean cyst nematode looks like within the egg capsule. The point is that eggs actually develop a little bit. The nematode actually develops a little bit within that egg before it hatches, and you can see that eel-like soybean cyst nematode coiled around inside that egg, wrapped up inside that egg, getting ready to emerge. Now let's go back to my slide, my photograph that I took several years ago when I worked for Extension, and you can see the little thread-like things at the bottom of the picture here. Those are the emerged juveniles. Those are immature soybean cyst nematodes. They are eel-like in appearance, as are other nematodes. You can see they start out looking like the other nematodes as far as a worm-like, eel-like body. They wind up looking like the big, fat, brown thing that you see right here. And these are soybean cyst nematode juveniles magnified, again from an Extension publication. I love this photograph because it shows some of those parts that we talked about earlier. And we actually showed this last time in our introductory session on nematology. You can see the needle-like mouth part. It looks like a T on the right-hand side of the screen. That's that needle-like mouth part, that stylet that will pierce the root and will begin to suck juices from the root, causing those yield losses we talked about earlier. This is a picture of those swollen females. Remember, the juvenile will, if it's a female, become pregnant, will fill with eggs, will release a portion of those eggs into the soil profile, but her body will swell up and take on this lemon-like appearance. If you want an idea of how big we're talking about here, just a good visual, you can see the little yellow round things on the screen here. These are actual soybean cyst nematodes on the root of a soybean plant that I collected in 2014. And that big white thing on the right-hand side is the end of a ballpoint pen, on the left-hand side, I should say, there. Now, remember, when we're talking about soybean cyst nematode, there are some symptoms that go along with that. These are one of the symptoms that people tend to look for. So they think about juices being extracted from the root, and they think about yellow areas in the field. And we can see that with exceptionally high populations, or when we have maybe moderate populations with a lot of stress. We'll run into this right here. But this is not necessarily what we will always see. There are sometimes above ground symptoms, but it is only sometimes that we see those. This yellowing of the leaf as juices, nutrients are removed from the root by those cyst females. This is another great extreme example of those above ground symptoms. Sometimes if you see these above ground symptoms, they'll have an oval-shaped pattern that tends to follow the tillage of the field or the way that implements were moved through the field. Remember, these things are being moved by implements, so it makes sense that you would have an oval-shaped area that stretches with the predominant tillage pattern. Again, this is the exception. It's not the rule. Sometimes we run into this, but most of the time we don't. Sometimes we also see a relationship with sudden death syndrome. Now, it is important for me to stress here that SDS and soybean cyst nematode can go together. They often do go together, but they don't always go together. For instance, I recently ran a cyst nematode analysis on a field that seems to have been hit pretty hard by SDS, and we had really low counts for soybean cyst nematode, and in one case, no counts of soybean cyst nematode. They tend to go together. They oftentimes do go together, but they do not always go together. The cyst nematode can house the fungus that causes SDS, and you'll remember that that SDS fungus actually starts out earlier in the spring. Just again, a sideline reminder here, this is the blue fungus, the blue fusarium fungus, infecting the root of a soybean plant, causing it to have those sudden death syndrome symptoms. Remember, it's chilly, cool soil conditions that really promote SDS, increase your risk for SCS. But again, there is sometimes this tie with SCN, and soybean cyst nematode management can be a valuable part of also trying to at least decrease your risk of SDS. This is the most important slide of the whole presentation, though, because this picture right here represents the most common symptom, above ground symptom, associated with SCN. You have beautiful green plants. In other words, there are no above ground symptoms oftentimes associated with SCN. You have no above ground symptoms, yet you still have those little females that you see here in the lower right hand corner of the screen, permanently attached to a single spot on the root, sucking juices, causing those 5 to 20% yield loss hits to occur. And yet we can't see it above ground. For this reason, we talk about sampling, soil sampling for SCN periodically to stay on top of it. You basically pull samples the same way that you would for soil fertility tests. 7-inch deep cores, you're collecting 10 to 15 of those scattered throughout the field so you get a good sample of that field, mix it together, you're sending in a quart bag to a reputable lab, and they will tell you what the egg count is and tell you if you have a situation that's getting critical and maybe causing some yield losses that you weren't expecting. That is the most important way to stay on top of this pest. What is the number one pest, once again, of beans? The fortunate part is that we have great resistance in bean varieties. And that resistance, even though it primarily comes from one parent, helps us manage this thing. Resistant beans basically kill off that permanent feeding site and cause the cyst to starve to death. And because of that, for the most part, we hardly ever have to engage in the use of chemicals to manage this soybean pest, this nematode pest. It doesn't work that way with all the other nematode pests that we run into in crop production. Well, thanks for watching. Just as we close here, I'll remind you one more time, soybean cyst nematode, we're talking about an eel-like pest that attaches to the root, swells with eggs, takes on this lemon shape. It's about the size of a period at the end of the sentence. We can't really tell anything above ground most of the time. We have to soil sample, and we have the fortune of this thing being permanently attached to the root system, to one spot on the root system, and resistant beans basically kill that spot and cause the pest to starve to death, requiring very little to no use of chemicals when we talk about SCN. Thanks for watching Session 2. We look forward to visiting with you in Session 3.